Hi everyone, today my team and I will be presenting our project for the Earth Systems Explorers team. In this presentation, we are going to examine how mosquito population dynamics are affected by urbanization. For some background, insect vectors like Aedes aegypti, Culex, and Anopheles genera spread diseases throughout the United States, such as dengue, West Nile virus, and Zika. With changes in the environment, mosquito behavior has changed significantly in the last few decades. Urbanization is a big factor in modifications made to the environment in which mosquitoes inhabit, prompting the question if urbanization actually impacts mosquito population dynamics.
Our goals are to gather mosquito population data to determine the extent to which urban settings affect mosquito breeding, use the findings to add on to pre-existing models, provide additional insight into one of the key contributors of mosquito population growth, and to create a predictive model to help prevent cases in urban areas in the event of a positive correlation. Through the Globe Data Access Tool and land cover and mosquito habitat entries, we expect to prove a hypothesis of higher urbanization associating with greater proportions of mosquito larvae. This will be done by using the data in graphs and tables to compare the density of mosquitoes in a localized area and prevent uncontrolled variables in our experiment, such as weather and water proximity. We will analyze our data and make a model based on the correlation between urbanization and mosquito population dynamics.
Okay, so just a little bit of background on our hypothesis. We chose to use an urban setting over a rural setting because urban areas tend to be hotter, and this is due to urban heat islands, which are caused by the lack of open space, greenery, and overall light colors in cities. With plants unable to provide transpiration and the darkness of common building materials with a low albedo, urban environments can create increased temperatures compared to their rural counterparts. Going off the increased temperatures in urban settings, mosquitoes tend to like higher temperatures, with them hitting peak performance at 80 degrees Fahrenheit, becoming lethargic at about 60 degrees Fahrenheit, and then completely losing all functionality at any temperature at or below 50 degrees Fahrenheit. Also, urban areas tend to have a lot more people than rural areas, especially in the United States, with urban areas having a lot more opportunity for the mosquitoes to feed.
The association we find varies greatly depending on the scope of the citizen science data we gather. First, we filtered data by only a handful of states in the same climate zone. We found a correlation coefficient of 0.55 indicating a moderate and positive association between our two variables, and 30.2% of the variation in larvae counts could be explained by urbanization. When we expanded the scope of our data to include several more states in that region and graphed that data, we found a correlation coefficient of only about 0.077, indicating a very weak association, and that about 0.6% of the variation in larvae counts could be explained by urbanization.
Some of our favorite features of the Earth Systems Explorers internship was the opportunity to collaborate with a group of like-minded peers, as well as learn from a diverse group of NASA scientists. One challenge of the internship was definitely creating an entire project from scratch and presenting it virtually.
Personally, I feel like I've learned a lot from the internship, and having the opportunity to work and collaborate with my teammates has given me skills that will last a lifetime.
As an intern in the Earth Systems Explorers group, I was able to analyze citizen science data, learn to use digital tools, and work collaboratively with my team to complete a project, and it's made me more passionate about exploring the intersection of business and computer science.
The Earth Systems Explorers program taught me many valuable skills which I was able to use during my research project and in the future. I had a great experience working with my team, and I improved upon my data collection and analysis skills.
I would like to apply my skill sets and my experience gained from this internship to future job prospects and internship opportunities.
The SEAS internship gave me the opportunity to work with other interns to accomplish a common goal in a set time. It gave me skills that will last a lifetime.
To wrap this up, we would like to give a special thank you to our fantastic mentors for all the help they've given us throughout the research. We also appreciate and admire the work from Cassie, Rusty, and most of all, we hold special thanks to Peder and his consistent positive outlook. Along with these wonderful advisors, we would love to express our gratitude to our peer mentor Jayden for getting the ball rolling and to our other peer mentor James for giving us feedback along the way. We can attribute most of what we've learned to their incredible backgrounds and willingness to help us become better scientists. Thank you all so much.